Hey everyone, this is Patrick Sackett. Just thought I'd go over just my quick implementation and solution for the lab for Lab 14, which covers, for at least for me, the Windows Component Object Model. Here I thought I'd go ahead and do a live walkthrough of how exactly I found and researched the COM objects necessary in order to create and write to files. Um, and then additionally, I would go ahead and walk through some of the source code I wrote that implemented the solution. So I thought first we should probably start with oleview.net. For this specific lab, the student is tasked with using oleview.net to research and find COM objects they think they can use to create and write to these output files. So at least the way I approached it with oleview was really just utilizing the search functionality using strings. So we can first kind of dive into this by checking for any class IDs by name. Here I'm just going to be parsing for anything with file, or I thought even file system would probably find us a COM object that we could use. Luckily there is what seems to be a file system object here. We can see it's implemented in this scr run DLL, and looking at the interfaces that are implemented for this COM object, we see again the iDispatch and iUnknown interface, and then we also see these iFileSystem interfaces implemented as well. One could also just query directly for these interfaces via the string functionality as well. So looking for the interfaces by name, we could query for either file or file system, and applying that filter, we'll see in the results again that same iFileSystem interface. So looking at the iFileSystem interface, we can go ahead and right click on this interface and check out the type library for it. Here we see the type library is the Microsoft Scripting Runtime DLL. So on the right side here we can see the iFileSystem interface. We can see a lot of methods implemented for this interface and even one property. This specifically, out of all of these methods, at least I found the create text file method to be seemingly the most interesting. We can see this method specifically takes 3 arguments, so a string for the file name and 2 optional arguments, both booleans, for whether or not we want to overwrite the file and whether or not we're using Unicode. And we can see a return for this method being a text stream object. So if we go on the left, we can see our iTextStream interface. We can see some more methods here. Specifically, we'd be interested in the write method, which takes a string for any text we want to write to the file, and optionally even a close method. So with that all said, at least at this point in the lab, one should feel comfortable with the COM object that they found. I'm not saying that this iFileSystem interface is the only way of going about it. Everyone's Windows system may have different COM objects depending on third-party applications installed. And just to quickly show, right, when we look at the number of class IDs, at least for my system, we can see there's over 8,400 available in this bottom left. And for interfaces available, you can see there's over 34,000. So one could spend days on days looking through the different objects and interfaces that are offered, as well as their methods, to find different ways to approach this specific lab. So with all that said, we can go ahead and jump over to the code. Here, at least, I'm just using Visual Studio 2022, but it really shouldn't matter as long as you have that file system object stored and implemented for your particular machine. So firstly, going down to the main method, we're really just doing 3 main things here. One, obviously, we're going to initialize the COM library via co-initialize. We're going to call our create and write file here, or write file functionality, and then we're finally going to unload the COM library. So jumping to our create file and write file functionality, is all it takes place in this create file COM method. A lot of parameters. We'll just kind of walk through each of these as we go through the methods that use them. So firstly, co-create instance takes 2 very important parameters: the GUID for the class object we want to create, and the interface ID in that GUID for the interface that we want for that specific object. Here we are just doing it in the same process, and some of the other arguments one could read on the Windows API documentation as well, play around if they'd like, but here we're really just mainly concerned with the class ID and interface ID, and then as a result we should get a pointer to our iDispatch interface, which we can then in turn use to invoke iDispatch methods. So here again we have our file system class ID and interface ID for iDispatch. The interface ID for iDispatch is implemented by Microsoft, so we don't need to define that. But the file system class ID, I did just define myself here in the header file for iFileSystem. One quick note that I should make is it is pretty easy to just to export the GUIDs in C structures in oliveview.net. It's very nice because we can just copy as a GUID C structure and you can paste it straight into your source code. So with that method succeeding, we should have a object successfully created, and we should have that pointer to our iDispatch interface. So from there, we know the method we want to invoke and get the dispatch ID for. So again, we'd be looking for this create text file function. So we use our iDispatch interface with the get IDs of names method. We're going to pass that function name. We're just going to run it as a user default, and then we're going to get back that dispatch ID. So once we have the dispatch ID for the method we want to invoke, next we have to set up the parameters. So if we look back at the method in the iFileSystem interface, we can see our create text file function again took 3 arguments. For our purposes, we're actually going to be storing them in the inverse order. So instead of file name or write Unicode, it will go reverse. But here is where we're going to be setting up the variants. So we have our variant for Unicode, which is going to be a Boolean. We'll set to false. We have our variant for whether or not we want to overwrite the current file, which I set to true. And then finally, we have our file name string, which is just set to the base C directory test, and we're just going to write output to test.txt, and that is going to be a B string. So once we have those variants set up, we can set up our array, which is going to be this args variant arg here. We only have 3 arguments, obviously, so we store them again in reverse order, and then we are going to store that array into a dispatch params struct. So here we specify the number of arguments we have, which is 3, and then the array of arguments themselves. Next we have the iDispatch interface invoke call. So here we're going to use our dispatch ID for the create text file function. Again, just running as our local user, and this is a dispatch method, so we're going to specify that in our flags. Then we're going to pass the pointer to our parameters, and here are just 3 output parameters we'll get back. So we'll get the resulting object or variant. We will get the exception information for if anything went wrong, as well as the error information. So after that invoke call, again, we get back what's going to be another variant. From this call, we expect to get back a iDispatch interface. So we can go into, if one were to look at the actual structure definition for a variant, we can see out of all the fields here, one of the possible returns is a iDispatch interface. So we call our invoke for create text file. We get back our what I believe was a text stream. Yes, text stream object, which is what that iDispatch interface is going to be for. And then we can go ahead and start to query and find our write function that we want to use to write to the file. So again, same thing here, just looks a little different. In our variant, we're going to pull that iDispatch interface. We're going to call get IDs of names. Again, we're going to pass our write string. We're going to run as a local user, and we're going to get back a dispatch ID. And then again, we're going to set up the arguments for the write function. If I remember correctly, the write function only took 1 argument, which was the string of text we want to write to our output file. So here again, we'll be using invoke. We're going to set up our 1 argument, which is the string as B string. We're just going to output this as a test string, and then again, we're going to reposition our arguments here in reverse order, but there's only 1 argument. And then we're going to go ahead again, use our dispatch ID. We're going to run as a local user. This is going to be a dispatch method, and then we'll set or set our array of parameters and get the output information. And that's about it as far as source code goes. So it is not in any means extensive or a lot of code, but it can be quite tricky to navigate some of the primitives when it comes to COM, when it comes to setting up parameters, and then navigating these COM objects and interfaces. So with all this written, we can also just do a quick live demonstration of the code here. So let me go ahead and bring over our File Explorer, and then here we will go ahead and run our Windows COM application. So again, we're in our C test directory. We should see a test file populate, and we should write this as a test string to the object. So from our output, you see we initialize our COM library. We create an instance of the file system object. We get the dispatch ID for the create text file method, which is 1101. We create the text file, and then we query for the dispatch ID for our write method on our text stream object, which is 10,007. And then we're going to invoke that method to write to the text file. So we open our text file, and we can see we have, this is a test string. So with all that walkthrough completed, hopefully everyone kind of gets a better understanding of some of the code and efforts that go into working with COM. It's a pretty intricate but very powerful protocol when one starts digging into it, and I highly recommend everyone kind of gets their hands dirty and play with some COM objects themselves. So thanks for listening.